Thank you. So first about me, before we talk about Go. My name is Janis. I automate things and monitor things. My automating things, I write mostly in Go. I do Kubernetes and other tools in AWS. Some people call me a DevOps engineer because of that. And Cozy, we are a cloud-native company. We do AWS since 2013 and are experienced in bringing legacy applications into the cloud and also to develop new applications which are cloud-native and in an agile fashion. We do this as a team, as a team of Cozy engineers for you. And we have every member of this inside our company. So if you want to develop an application, we create a team which fits perfectly to your needs, and no offshore work, and everything is developed in Darmstadt in our office. So that's about our company and me. Now let's talk about Go. Who here uses Go? Oh, more than I thought, but for you again, maybe you get some more information and do Go for other tools or for other things too now. So why should you write a script when you could also use Go? Go has an absolutely clean syntax. It has no magic involved, so no Java annotations or stuff. You also have no constructors, no generics. You don't even have exceptions. You don't have inheritance. Coding in Go is absolutely different from coding in another language. And yeah, sometimes you have to write some more lines of code, but it makes easier for you to understand the code later on. You have Go is one of the first programming languages which was developed after a computer had more than one processor most of the time. So Go was developed with concurrency in mind. You don't have to deal with threads and stuff. Go does that for you. And Go has absolutely powerful tooling. Everything you need to develop Go is inside one single binary, the Go command. And you can create, it is absolutely quickly compiled to assembly, also statically compiled so that your code can run with 0 dependencies, so no npm install or whatever you need. And you can also cross-compile it to other operating systems or processor architectures with a single command on from every host to every other host. It also has garbage collection. Yeah. It feels like home for you. This is the hello world emoji style in Go. Yeah, really important. You can use emojis in strings. I don't know if this is the killer feature for you. There you go. And every file, every Go file is in one package. In this case, it's the package main. And yeah, you use another package, the FMT package, to print the line which says "Hello World." Yeah. Also, Go comes with a big standard library, which contains logging, compression, crypto services, the file handling, TCP/IP, web servers, SSH, and modern TLS support. Even HTTP2 support is included. And also a templating engine you can use for text files or for HTML, so for nearly everything you need. And another really important feature is that that Go has no breaking changes in every new release till Go 2. So there was no breaking change since March 2012. And so your code from March 2012 will run today as then, but today with a newer Go version. So bug fixes and performance improvements are there. Everything you write is a library. And you can pull libraries just like this as from a GitHub repository. So you import a Git repository like this and can use it are here. So all these lines do create a web server saying when you curl /ping, it answers Pong. So not that much code for also not that much of a function, but it works and everybody understands what this code means. There are typed and generated clients for each and every major cloud provider and other API you will find out there in the wild. And most of the time they are official, so they are updated when the API is updated. So the Kubernetes client Go is used inside Kubernetes, for example, or the Docker client is also used inside the Docker CLI. The generated clients often don't use that much of reflectional code, so they are even faster, and most of the time they are statically typed, so you don't have that much of magic strings or blobs of JSON you put into a bash script when you want to curl, for example, something inside that bash script. So you can't do that much of misspellings. And of course, if you're looking for the perfect library that fits your needs, Awesome Go is there to help you, as for every other language out there. I talked of the Go CLI. One of the most important commands you will see in the beginning is go get, because that's the way how you download other libraries and other stuff. And also, if the library has a main package, so will be compiled to an application, you can go get it, and it also and it will be compiled to your Go binary folder. So when calling this, you actually pull or clone this Git repository and install that application and compile that application to your Go bin. And can use it as deb. Deb is a dependency management tool for Go, but it also works with many other tools. For example, you can get Caddy that way, but because it pulls always the master, that's not the best way to do it, but it works. It also is a good way to clone your Go projects to the right folder. So here's your free #1 Stack Overflow answer. Please just write that down or get it from somewhere. You will need that line of code if you want to pull or clone with GoGet a private Git repository if you have two-factor authentication and pull over SSH enabled. What you mostly have, I hope. So now, how to start going? These were the basic facts about Go. Maybe you do want to write your first Go code for now. At Cozy, we started to use Go not because we wanted to automate things and because we wanted to use cloud APIs. We wanted to automate a headless Chrome instance and had an npm package which called that via JavaScript or TypeScript, but it was really buggy, didn't work at all, or was absolutely weird to use. So we tried the generated Go client. It was at first it was hard to learn the new language, but then we began to use Go for other tools. So now we use Go to create CLI tools and microservices, and also to automate things, for example, in AWS. So now I will show you the main parts, or the gotchas, which are different in Go than in other languages. So what I say, no, we don't have classes. We only have structs. But the good part is, on structs you can also define methods like this. And you don't have constructors. Because of that, you just have to write a normal function. Also, this is the way how you create a new struct. And if this is right lowercase, it is package private, and if it's right uppercase, it is a public struct. So if this is written public, this code can be executed from everywhere. So you have to take care about that. if your struct needs to have some values initialized or not. But when we don't have classes, but at least we have interfaces. So if you want to use cars and trains some way the same way, because they can both move, you can define this interface, and interfaces in Go are implicit. That means you don't write the typecast structs implements blah 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 here. Every struct which implements a function called move with that signature automatically implements that interface. For example, mostly important interfaces are an I/O writer, reader, and stuff like that, because you read files and file streams and from TCP and from everywhere else with that. So also error handling is a bit different in Go, because I said we don't have exceptions, we don't throw stuff around, but we have this error thing here. So the normal way in Go to handle errors is that you return multiple values like this. So you will have more than one return statement in your application or in your function, and just return nil for the first value, and something went wrong error right behind here. So most of your code will look about like this down here. So you will do things like, I want to get my result, but maybe there's an error. Okay, if the error is nil, I have to handle it. If not, I can continue. The most important thing is, please handle your errors and don't ignore them. It's done like this so that it's explicit and not like Java, where you just throw runtime exceptions because you don't want to handle all your errors. But what do I do if I don't need one of these return values? I can also ignore it with an underscore like this. It would also work with an error, but we won't ignore errors, so I won't show you how to do that. It works the same. And what you can also do, because you have multiple return values, is that switch that statement which switches the values of those two variables in one line. Another interesting thing, because you will write return value returns in most of your error handling tools, is the defer statement. The defer statement calls right after a return function, but it doesn't matter which return function it calls down here, right after that. And you can use defer multiple times if you want to close more files or stuff like that. Also, what is really important for you, please test all your things. Testing all the things is really hard if you write Bash script and some other languages like that. And Go has a testing framework right included. This test framework also includes race detection and stuff like benchmarking. Every file which ends with an _test.go is treated as a file containing unit tests, so won't be compiled if you compile your code normally. But if you execute the test, this code will be compiled and tested. And you call that like normal Go code. You write your testing, you write your test up here, and you assert your stuff down here. There are also asserting frameworks available. We will look into that later. And as I said before, one of the interesting things in Go is the way they handle concurrency. Because Go was created with concurrency in mind, logs, mutics, and callbacks are still available, but less used. Threads are managed by Go. You don't have any access on how threads are created and so on, because Go uses a thing called a Go routine. and a Go routine has a much less memory footprint and starts even faster than a thread. The way Go works is you should communicate over channels, so message-based between the Go routines and not with shared memory or logs and mutexes. So how does a Go routine work? You write a Go in front of the function, and it's a Go routine. Yeah, but what are the trade-offs? You don't get any information about the return value, and yeah, but we will look into that later how we do that. The other thing is the Go routine is now really fire and forget. If you write it like this, the function is, as every normal function, just blocking and waiting for it to be executed. The Go function here will then be scheduled somewhere else, and the code will here then be continued. So what do we need to talk with different Go routines? We need channels. Channels look like this, and I don't know channels from any other language, at least in this way. So you create a channel which contains strings and send strings to that channel and get strings out of that channel. And this code is blocking till some other Go routine calls this part and gets that channel. You can also make buffered channel which then aren't blocked, but this is the normal way of communicate between Go methods. So this is the full example of the code before. You start a sender and a receiver Go routine, and they execute that code. And as you see, we don't return any errors or so because we can't handle them. What this gives us is that it's really easy to do stuff like the worker pattern. We create 3 workers. These are Go routines, or think about it as processes, which are waiting for jobs, because they get their jobs in the jobs channel, and when they get a job, they do that hard work of sleeping a second, and then returning the result into a result channel. And what in the main function is doing, it sends jobs into the queue, which can maximum hold 100 jobs, and then blocks, and then waits for the results and gets that back. You can also do this somewhere else. It's absolutely thread safe to call channels, to send to channels and read from channels from every Go routine you want to. So I said receiving is a blocker. If there aren't any jobs in the queue, the code just waits here, so it does nothing. Sometimes you want your code to do something because you want to handle a timeout or something like this. There's a statement which is nearly like the switch case statement. Here, the channel which returns a value first will be executed. So if you get in the first 10 seconds something from this channel, this code is executed, or after 10 seconds, this code is executed, and you will continue. So now, what do you need if you want to Go? You need a Go installation from golang.org/download, or for Linux, the best way is to use Snap, or for Mac OS, you can use Homebrew. And on Windows, I think the best way is to use the official download, or there's Chocolately or stuff like that. You need some text editor, but please don't use Notepad.exe. Use Visual Studio Code, Goland, or Vim, because they have Go plugins which do the heavy lifting of formatting code and stuff like that for you. And also the built-in tools you heard of today, and you will see now and later on. So let's go. Sorry, I'm not done. I have a demo. Because I wanted to show you some Go code and how a Go tool is how a Go project is structured. As I said, you have a package main which contains a main method. This is the entry point of your application, and then you have some other packages around there which do most of the logic part. So I wrote a simple image converter because I don't want to introduce you to different AWS or Docker APIs, but image conversion is a thing I think most of us have done in any way before. So this tool does nothing else than you give it a source directory and an output directory, and then it crops the image, so it creates thumbnails. And it does it with a worker pattern, and it also has two different cropping technologies inside. So here we define some flags, the source and output directory, and if we use our really good smart cropping technology. And this is the processor by itself. When we create a new processor, it creates 1 to 20 workers, which then can handle 1 to 20 images at the same time. And we have a job channel which contains the new images, and later on a stop channel which contains stopped workers. And our worker does nothing else than getting a job, and if it has a job, it processes the job and writes a log message if it has processed the file successful or it handled an error. It had an error. So now we can run this code with the go run command, and then say we want to run the main.go file, which is here, and then we will see, oh, no error message. I didn't do error handling here. Nice. Maybe a help? Yes. So this help is auto-generated out of the flags which we defined before. So we do this now with the source directory test and the output directory test/out, and then our application processes all the images, and about I think five per time, and we had one error right here. You can also use the worker pattern if you want to automate stuff on, for example, AWS, and want to start more instances on want to start different instances, or waiting for containers and stuff like that, because it's no problem if you have a Go routine which is waiting, because it doesn't have any or at least no big overhead for you. The other thing I wanted to show you today is that the way Go auto-generates code, and auto-generating code is most of the time a good way for you to learn to create code which is better to debug for you. So I had to write a client for an TCP for a weird TCP protocol, and I first tried to do it with reflection, which is the way you would do it in, I think, every other language too, like in Java or C#. But I didn't get it to work because it was really hard to debug for me. So I decided to try out code generation in Go, and this is the message structure. So I want to receive a hello message, which contains those two ints and two strings. And I want to create a receive method for that. I then use the Go templating engine to write code which looks like this. And yeah, I think you probably won't understand what the code is doing right here. I created this code, so I wrote the first receiving function by hand, and then added the replacements here to match it and to create the resulting code. I created then a command line tool, which is executed every time I add messages to the message.go file, and the resulting code looks like this. The file is huge, and you don't want to write this by hand, but we will see our hello message here again with the generated code, and now I could see where the code failed because I could easily debug through the code and step through the code, and I absolutely got that code to work. And yeah, finally it was also about 10 times fast as if you would use reflection. So these were the short 2 demos. As you can see, you can do much things with Go. Sometimes the code looks a bit weird. Sometimes it's a bit different than you were used to the code in Java or other languages. But it's really good to have typed clients and at least official clients, for example. To have official clients for Kubernetes and stuff like that. So where should you use Go, or where you could think of using Go? Start with a server application or a simple microservice. Creating a web server in Go is totally easy. It's about 5 or 6 lines of code for the first part. You absolutely create really small size Docker containers which run on any platform, on Raspberry Pis, on your servers, on I think Windows 2 and stuff like that. Also, CLI tools are a good use case because you can distribute the binaries which are statically compiled to your colleagues, and they don't need the Go toolchain installed. And you have the official library for almost every cloud service you can imagine. So where to go now from here on? There's the Effective Go official guide and link to some other learning resources. And the demo code is down here on GitHub. Everyone done with the photos? So that's about the talk. And does anyone have questions? Yes.
You showed the generated code from the template.
Yes.
Is that code on runtime generated, or do you generate it once? It's a file and then it's it?
No. The interesting part is it's generated not at runtime. It's generated before. So I have a command line tool which generates the code for me when I want to. So you will do that in continuous integration and stuff like that. And most of the time, you want to add the generated code to your Git repository, so that other people don't need the code generator to use your code. And so the code is on your disk, and you can just step through it, and it's not somewhere in.
Okay, thank you.
Other questions? Okay. Yeah, is there some kind of distribution if you write command line applications? For example, if you have a nice command line application and you want to distribute it to your Windows using colleagues and to the Linux using colleagues, that you just distribute the exe and whatever? Or do you have something like pip for Python, for example?
Yeah, you could tell your colleagues to just run go get, or the better way is that you create a private brew or a snap repository for that binary. And it's really easy for you to create that executables, and how to distribute them is then in your hand.
Okay, so nothing really like pip, for example, for Python, where you just tell everybody that pip download.
No, but you can, for example, create it.
Okay. Okay, thanks.
Maybe in answer to that, I think distributing stuff as Docker images is really helpful. Docker as a command line wrapper, because each Docker run will check for a new version and use that. And you already must have Docker repository infrastructure if you come to this conference. And it even works on Windows with Docker for Windows, so that you don't have to burden everybody with the whole build environment. And you can even write your command line tools in other languages if you fancy them.
Yeah.
Good option. Okay, more questions? No questions?
Okay,
what can do for you?
If you have any questions later on about Go or AWS, step by our booth in the downstairs. We're here today and tomorrow, and we want to talk about AWS, Go, and other stuff if you want to.
Yeah, nice, thanks.